to show some examples of addition of rational expressions, and hopefully this will help with some of the homework that you have coming up. But anyway, addition of fractions where the denominators are not the same. You have to be careful about this. If ever there's a plus or a minus in the denominator or the numerator, I like you to put a parenthesis around it and think of it as a unit that has to be exactly the same as something else when you're doing your addition and subtraction of rational expressions. So I cannot add these two expressions because they don't have the same denominators. So what do I do to get the denominators the same? I hope you realize that you have to multiply, and whatever you do, you have to multiply the top and the bottom of the fraction with the same thing. For example, if I was going to add x over 2 plus x over 3, I can't add those because the bottoms aren't the same. This one I would multiply by a 3 on the top and the bottom. This one by a 2 on the top and the bottom. And then I would have 3x over 6 plus 2x over 6, and now I can add the tops and get 5x over 6. These two fractions, the bottoms are not the same. When you make the bottoms the same, you have to use multiplication. So, just like this was a 2 and this was a 3, they were totally different. This is an x and this is an x plus y. Those are two totally different numbers. So I'm going to multiply this one by x plus y over x plus y, just like I did 3 over 3, and this one by x over x, just like I did the 2 over the 2. So watch what happens. X plus y over x plus y times a over x plus x times b over x times x plus y. Now you'll notice the bottoms are the same. So my answer is going to have the bottom x times x plus y. I'm going to distribute the tops though for multiplying here. So ax plus ay plus bx. And I double check to see if there are any like terms I could add together. For example, if this was ax plus ax, I could say 2ax, but it's not. So there is the final answer for that fraction. All right, let's try another one. Do you know what the common denominator for this expression is? I hope you notice that on this one I'm going to multiply by, first use parentheses if these are plus or minus, I'll multiply by x over x, and this one I'll multiply by a plus b over a plus b. So now my answer is going to be x times a plus b. And it's best to leave them in factored form and you don't have to multiply those out. On the top I have to multiply it out just in case I get some like terms. X times 4x, 4x squared. X times a, ax. C times a, ca, c times b, cb. Look to see if I have any like terms to add together. I don't, so there is the final answer. All right, I'm going to clean my board and then I'll do one more. All right, so I have 3 parts to add. Here's a fraction, here's another fraction, and this is a whole number. But if I have 2 fractions, I'm going to make the third one a fraction by putting a 1 underneath. Now, the common denominator has to be all of these or some combination of multiplying them. So I guess 1 times x times m. 1 times anything doesn't really change it. So we're going to just say that the common denominator is xm. So let's put parentheses if you ever have a plus or minus on the top. All right, so what does this one need to be xm? It needs to be multiplied by m. What does this one need? X, right. What does this one need? Ooh, both x and m. X and m. All right. Now, just the process. Let's do the multiplying. M times A, am. M times B, bm. X times C, xc. D times xm, dxm. Now I check. This could be the answer, but maybe I have some like terms. No like terms. So, final answer right there. Okay? Good luck on the homework.